Hi, this is Justin Laughlin. This is my Labview project for ENGR267, engineering programming at Oregon Tech with Professor Mateo Voy. There we go. All right. Right now we are looking at my function generator. I chose to go a little different as far as the style is concerned and not really use a traditional oscilloscope or a function generator image. So I used an old console television. All right, here we go. So right off the bat, I've got everything set at its zero position. Right here is my waveform selector, so I can go through sine, square, triangle, sawtooth, or DC. So let's set a frequency, and let's get an amplitude going. I can adjust my amplitude here, as well as my frequency here. Start there. For the waveform selection, I can do sine wave, square wave, triangle, sawtooth, and our DC signal. Go back to sine wave. I can add an offset if I so choose. I can add noise, which I have white noise in Gaussian. To add white noise, select it, and here's the intensity of the noise. And we can also select our Gaussian noise right there. I've also added in plot color, so you can change your plot color to any color that you so choose. I'll choose purple. Let's get the noise off there. I've also added an ability to increase the plot line width. And down here are the measurements, so we can see that we have an amplitude of 2.07, frequency of 128, and our min and max voltages, as well as peak-to-peak voltages. On the next tab, or the next window, we can look at the FFT to correspond with the same settings. So here, if I increase my frequency, you can see the peak move, as well as the amplitude can go up as well. Choose through sine wave, square wave, triangle. Now we can do sawtooth and see the other little peaks that is created here. All right, so if we scroll over, we can see the same stuff in this next old television console. Go back to a sine wave for this one. Do a pretty faster frequency and a smaller amplitude. And we'll go over here. Likewise, this is being fed from the function generator. And in here we can see that we just have a sine wave, 200 or so frequency, and a 200 hertz frequency and a 2 volt amplitude. Currently, we have volts per division and milliseconds per division on the time scale here. Right here we can go to 5 millivolts per division, 1 volt per division, 2 volts per division, and 3 volts per division. And for the milliseconds, right now we're at 20 milliseconds per division, 15 milliseconds, 10 milliseconds, and 5 milliseconds. I've also added the ability to change your vertical positioning. Here, you can reset that as well. And additionally, to change your plot color. If you want to add some funky color to your waveform. Blue's too hard to see. Let's go back to green. Plot line width as well. We can increase that. And have the ability to trigger on any one of these, any waveform that we have. Trigger there. And then the ability to save the image. So save the image. Get a dialog that pops up. Choose where you want it to go. Desktop. Save it here, sure. New file. And test image. Say OK. We'll save that to the desktop, as well as we can also save the file as information from our waveform enter signal. So right here we're saving it as an elapsed time. So we can keep this going and create and save as many data points as we want. Stop that. And that should save it to the desktop as well, where I saved the last one. And here we can reset the time. All right. And I'll just stop it from here. And right here we can see the test image here that we've saved, and the test data, which I'll just open with a text editor. Once it decides to figure out what it's doing, text edit, there we go. And there's the saved data. All right, so hope you enjoyed the project, had fun making it, stuck with the basics so I could understand more about what was going on. But this is my function generator and oscilloscope. Hope you enjoyed. Thanks.